Today we'll be going over logistic regression, which is a statistical model used to predict a binary outcome based on one or more independent variables. And unlike linear regression, which predicts continuous values, logistic regression estimates the probability of an event occurring. So I mentioned this before in a previous video, but despite having regression in their names, they are completely different, and they're used in very different scenarios. So a logistic regression, it uses a logistic function, hence the name, and we call this function the sigmoid function. So uses and basically what this does is it transforms its output to a probability between 0 and 1. And yeah, basically the purpose is to produce a kind of like 0 or 1 like binary output so that we can determine whether, based on the input, like kind of like the output, on what if it's going to be closer to 0 or if it's going to be closer to 1. So yeah, we have like a defined threshold. So like I said before, it's like going to give us a number between 0 and 1, and then we're going to decide whether or not that number is close enough to 1 or close enough to 0 to determine our output. So we have kind of like a threshold. Classifies the outcome as 0 or 1. And usually it's 0.5. So what are the key components? So first we have the dependent variable. It's a binary output from 0 or 1. And then we have the independent variable. And yeah, this uses, these are like the features used to predict and then produce the dependent variable. So features used and then we have the coefficients, and basically we have like a bunch of independent variables or features, but not all of the independent variables are going to be as important as the other variables. Like for example, if you have like a house, obviously this is not a really good example, but let's just say we're trying to use logistic regression for a house. We want to determine if it's a luxury house or a cheap house. Then maybe something like if it has like a dog door, that might not be like that might not be as important as like the area of the house. So we have coefficients, weights. And then we have the intercept. You can think of it as like where it intersects the y-axis, so the value when all features are 0. Okay, so what is logistic regression used for? There's a lot of, it's one of the more common ones, but you can use it in basically like anything. So, for example, medicine. I probably explained this before, but you can use it to, let's say, determine whether a tumor is malignant or benign. So you can basically predict disease occurrence. You can also use it in like marketing, finance, etc. And then finally, you can use it in machine learning. And this is probably where it's used the most, but it's basically like a kind of like the bottom line classification algorithm for, let's say, a more complex machine learning model. And I'm going to be talking about some advantages and disadvantages. So advantages, we have that I guess it's like very simple interpretable. It's 6, 0, or 1, and like you're going to be given an output value, and then you just have to determine whether that's close enough to 0 or close enough to 1 to be like called or considered 0 or 1. So simple and it's also very efficient for training and prediction because again, there's only two types of I guess outputs, and yeah, this is gonna sound like very similar to a binary classification algorithm. And yeah, logistic regression we can use a lot for binary classification. So efficient training and prediction. Also provides probability scores. So basically, our dependent variable, the output, is going to give us some number between 0 and 1, and that's basically kind of like you can think of it as a probability, or like how close it is to each number. So provides probability score. And yeah, so there are also limitations, of course, and these include assumes a linear relationship between features and log odds. It may also underperform when the features involved are very highly correlated, so underperforms. And another disadvantage is that it can be prone to overfitting with small data sets. Yeah, so that's kind of like a brief overview of logistic regression. I didn't really talk about the algorithm itself and like, the implementation of it and that stuff, but I'll be going over that in a future video. But yeah, thank you for watching.